Hey guys, welcome to question FM 340 of the Further Maths Fortify study guide. This question reads, little Johnny is designing a kite. His design is shown in the figure below, and then we're given a diagram that looks much better than mine here, but you get the idea. We're told that the kite has a length of 787 millimeters and a width of 420 millimeters. Question A, part I, says, what is the value of the angle alpha correct to the nearest degree? So having a look at this angle here, what we can start to see maybe is that we've got two isosceles triangles sort of meeting at this point here, sharing this right angle, which means that if they're both sharing it and they're both similar to one another, they're sharing half of that each. So these angles down here in the corner are going to be 45 degrees and 45 degrees. Using two of these to make up alpha means that alpha is simply going to be 45 degrees plus 45 degrees, which means that our answer to part I is going to be 90 degrees. Angle alpha has a value of 90 degrees. Going on to part II, we're asked what is the value of angle theta correct to the nearest degree. And this one's a little more tricky, but still very doable. If we took a right angle triangle out of our kite here, so this bottom left quadrant, for want of a better word, we would have a shape that looked like this. And what we would know about this shape, number one, we know that this length here is 420, which means this midway point here, it's going to have a height of 210 millimeters. This same length that's found here is also going to be found here. So we know that this length here is 210, the full length is 787, so this length here is simply going to be 787 minus 210 millimeters. Now we can figure that out, or we can just leave that as is for now. We're going to be looking to try and find this angle, which we'll call x at the moment, which will make up half of the angle theta we're being asked to find. So we know that we're going to be using the formula tan theta equals opposite over adjacent, considering that we have an opposite and adjacent length. So substituting our known variables, we have tan x is equal to 210 over 787 minus 210. Rearranging for x, we are going to get arctan of 210 over 787 minus 210. And finally, theta equals 2x. So this is going to be equal to 2 times arctan of 210 over 787 minus 210. Plugging this into a calculator and rounding to the nearest whole degree, we should get an answer here of 40 degrees. We're then given a little bit more information. So our diagram changes again to look like this, and we're told little Johnny, being an artist, is coloring in his kite with circular shapes. The design of the kite is shown in the figure below, and we're shown a figure that looks much better than this one. The circles have a radius of 210 millimeters. What is the area in square centimeters of the shaded region? Round your answer to 2 decimal places. So the way we answer this question is, first of all, we're going to find the area of the kite. From that, we're going to minus the area of these circles, or the parts of these circles. And then we're also going to convert this to centimeters squared, because all of the units that we've been given to start with are in millimeters. So we're going to have to convert this into centimeters at some point. I choose to do it at the end. So following this, the area of our kite is quite easy to find. We simply take these diagonal lengths, multiply them together, and then halve them. So the area of our kite is going to be half 420 times 787. And adjusting, well, calculating this now, we should get 165,270 millimeters squared. The area of the circles is a little more tricky, but not too bad. So we're going to be using the area of a circle and then multiplying that by how much of this circle we're using, meaning that these two circles are in fact the same size as one another. They both have a radius of 210 millimeters. So rather than treating them as two separate circles, we could just treat them as the same circle. And the way we're going to do this, find these two angles that make up this circle and add them together. Now we should know that in a four-sided shape, all the angles should add up to 360 degrees. So if we minus from that the 90 and the 40 that we found before, we should be left with 230 degrees. So with these circles, we know that the radius is going to be 210. And we now know that the angle, both of these angles together, are going to leave us with 230 degrees over 360. Now, bringing this all together, the last thing that we're going to have to look at is the conversion for millimeters squared to centimeters squared. So millimeters to centimeters, you may remember that this is going to be divided by 10. But since we're looking at millimeters squared and centimeters squared, we're going to divide by 10 squared. So to bring this whole thing together, the final area that we're looking at, we're going to take the area of the kite, 165,270. We're going to subtract from that the area of the circles. So we're going to subtract pi times 210 squared times 230 over 360. And then finally we're going to divide that whole thing by 10 squared to land it in millimeters. Doing all of this should land us with an answer of 676.56 centimeters squared when rounded to 2 decimal places. And this, of course, is our final correct answer. If you guys have any questions about this question, please leave them in the comments below. Otherwise, I'll see you in the next video.